something on this screen on the board. So here we are considering a unit circle as has been the case before. So let's consider that unit circle and two angles. So I have two angles. One angle is alpha and the other angle is beta. So of course measured anti-clockwise. So we have those two angles. One as a point on the circumference, which is Q, and you can see that Q has coordinates cos alpha and sine alpha. So that's what we saw last time when we were using a unit circle. And also the angle beta gives us a point P, and this point has the cosine of beta and sine of beta as its coordinates. So now our interest is the difference in the two angles. So we have the angle alpha minus the angle beta. So the angle alpha minus the angle beta is what gives us this angle, which I've called the alpha minus beta. So now we are interested in knowing let's say the sine and the cosine of alpha minus beta. So here we are going to use what we know, of course. So I've said that let the distance between P and Q be noted as D. So you remember that when you had 2 points, a line linking 2 points, you were able to find the distance between those 2 points. So we are going to use the distance formula. So you have a distance formula, which we know in this case, because the coordinates are given. So from the distance formula, we have that D will be equal to the square root of cos alpha minus cos beta, all squared, plus sine alpha minus sine beta, all squared. So this is the distance formula that you have used before, and you, of course, you now just need to simplify, or rather expand and simplify what you have. But let's square both sides first. So we have that D squared will be equal to the cosine of alpha minus the cosine of beta all squared, plus the sine of alpha, sine alpha minus sine beta all squared. So all we need to do is just to expand and simplify what we have. So the first expansion is the following. So you have cos alpha squared minus 2, because there'll be 2 of them. So you have 2 cos alpha cos beta. So you have cos alpha cos beta, and then plus cos squared beta. Then the second expansion will have sine squared alpha minus 2 of sine alpha sine beta, and then plus sine squared beta. Right, so that is the expansion that you get. The next thing is just to look at some common terms which we are in terms of an identity. So for instance, we have cos squared alpha. Then here we have sine squared alpha, so we can add sine squared alpha. And then the next term is 2 cos alpha cos beta. But then you can see that these are, of course, two of them, or rather, let me write it in this way. So you have 2 of cos alpha cos beta plus sine alpha sine beta. So that those are the ones that you have here, those terms with a negative, of course. And then the last two terms that we can think of are sine squared alpha, and then sine squared beta plus cos squared beta. Right, so of course, we've done this so that we can actually look at the common, should I say, the identity. So in this case, if you look at this and that, we see that this is an identity. So cos squared alpha plus sine squared alpha is equal to 1. And then also sine squared alpha, or rather beta, plus cos squared beta is equal to 1. So I'll just say this is 1 plus 1, which gives us 2. And then you have minus 2 cos alpha cos beta. And then, of course, minus 2 sine alpha sine beta. Okay, so this is what the distance formula gives us when we consider the distance formula. Is there any question before I proceed? All right, so if there is no question, then let's do another thing. So we found d squared to be equal to what we have here. Now, let's say move the point P so that it is at that point. So we just move it along the circumference and then just bring it at that point, and then also consider the distance formula. So I wanted to clear this board so that we can use it for the next. Right, so saying now, let's say just note that what we had is d squared is equal to 2 minus 2 cos alpha cos beta minus 2 sine alpha sine beta. Right, so that is what we found earlier. So now we're saying that we can try to move the point. Let me try to draw the triangle again. Okay, so Again, we are considering a unit circle. So we are saying that the point P now will move to on the x-axis. So in this case, I'll call this point, let's say P prime. Now, the coordinates of these points, remember that the radius of the circle is 1. So this will be just 1, 0. Right, so we are saying that we are moving that triangle that we saw earlier. So our point now, let's call this point Q prime. And we are saying that this angle here will be now alpha minus beta. So that is the angle that we have. And of course, our triangle is this triangle that we'll be considering. Right, so it's the same triangle, but just move it in such a way that the point P comes to P prime, and the angle remains the same, which is alpha minus beta. And then we can call this distance D. So here we are saying that Q prime, or rather P prime to Q prime, let me write it properly. So P prime to Q prime is equal to D. So let it be that way. Now, what are the coordinates of Q? Again, the angle is alpha minus beta. So the coordinates of Q will be the cosine of alpha minus beta, comma sine of alpha minus beta. So those become the coordinates of this particular point. So now, again, if we use the distance formula, the distance formula now here will be D is equal to the square root of the cosine of alpha minus beta minus 1 all squared, then plus, again, sine of alpha minus beta minus 1 all squared. So that becomes your distance. So again, we can just expand and simplify this. So if we expand and simplify, let's see if we can do the expansion. I hope you can still see what I am doing. Right, so what we are going to get is the following. So you have the cosine of alpha minus beta all squared, then minus 2 of the cosine of alpha minus beta. So here I'm doing d squared. So I'm just going to do d squared and then expand. So the first expansion is what I am doing, and then plus 1. Then next you have sine of alpha minus beta all squared minus 2 sine alpha minus beta, and then plus 1. Are we together? I had a glitch in my internet, so I hope we are following. Yes.
The recent image and added the recent image. So when you're asking where you're putting that, it's just after cos beta minus alpha, or alpha minus beta, then there is a -1.
Yes. So actually, I've made a mistake here. Right. So here we have cos alpha minus beta minus 1. So remember that we have two coordinates. There's this coordinate p prime, which has 1, 0. The other coordinate is cos alpha minus beta and comma sine alpha minus beta. So using the distance formula, it will be this one, x1 minus x2, and then y1 minus y2. So that's what I was writing here. So I said I, of course, made a mistake. So in this case, we don't have one term here. I hope that clarifies before I move on. Any other question or clarification? Right, so when we expand, of course, what we are going to get is what we have here. And then moving on, we have that d squared will be equal to the cosine of alpha minus beta all squared plus the sine of alpha minus beta all squared minus 2 cos alpha minus beta. Right, so the first one is an identity. So this is just going to give us 1. So I've left a 1 somewhere, this one here. So let me add it there. Okay, so this gives us an identity, which is 1. So we have 1 plus 1, which gives us 2. And then minus 2, the cosine of alpha minus beta. Right, so this is d squared. So now, what we know, or what we can see, is that d is equal to d, or rather capital D is equal to small letter d, because remember that we are dealing with the same triangle in this case. We have just moved it around the circumference of the circle. So those distances are the same. So in this case, then d equal to d means that we must have 2 minus 2 the cosine of alpha minus beta. This should be equal to what we got earlier, which is 2 minus 2 cos alpha cos beta minus 2 sine alpha sine beta. Right, so then we can just try to simplify things. And so we see that in this case, 2 will cancel out because it is there on both sides. And then we remain with only those. So here, if we divide through by 2, what we are going to get is the following. And I want to call this identity number 6. So you get the cosine of alpha minus beta is equal to the cosine of alpha, the cosine of beta, plus the sine of alpha and the sine of beta. So that's what we have. So given any two angles, alpha and beta, then we can get the cosine of their difference, which is alpha minus beta, and it is given in this particular way. Is there any question? So again, if you have a question or you want to clarify something while I'm talking, please feel free to be able to interrupt me. Okay. So then we can actually get other identities from what we have so far. Let's see if I can delete what we have and then move to the other identities. So identity number 6 is the cosine of alpha minus beta is equal to the cosine of alpha cos beta plus sine alpha, sine alpha sine beta. Right, so if we substitute or replace beta with minus beta. So let's see, I'll just let beta be equal to, this may not make sense. So let's replace. Let's replace beta by minus beta in 6. So if we do that, then we see that what we are going to get is the following. So I'll just call this identity number 7. So where there is beta, we put minus beta. So that will just be cos. Okay, so those on Zoom, you are back.
Yes, sir.
And on Google Meet, you're able to hear me? All right, so I was saying that if we substitute in 6 beta 4 minus beta, what we are going to get is the following. So in this case, we have, of course, alpha plus beta, and this is equal to the cosine of alpha, and then the cosine of minus beta, plus the sine of alpha, and the sine of minus beta. Right, so you remember that the previous lecture, we saw that cos of the negative of an angle is just that angle, or it is just the cosine of that particular angle. So in this case, what we get is the cosine of alpha, and then the cosine of beta, plus here what we know is that sine of a negative angle is just the negative of the sine of that angle. So in this case, we are going to get negative sine alpha, sine beta. So this is our seventh identity. So the cosine of alpha plus beta is just going to be the cosine of alpha times the cosine of beta minus the sine of alpha times the sine of beta. Right, so those are the two identities that we get from what we have done. So let's see if we can look at a particular example. So let's find the exact value of the following. So find an exact value. For cos 5 pi by 12. Right, so we want to find the exact value of cos 5 pi by 12. Now, for us to be able to do that, if you look at 5 pi by 12, it is not a standard angle. Who can tell me what the angle this is? 5 pi by 12 in degrees.
It's going to be 75.
75 degrees.
Yes.
I hope so. Right, so what we are going to do is for us to find standard angles. So you said 75 degrees. Let's find two angles which are standard that we are going to add for us to get 5 pi by 12 or 75 degrees. What are those angles? Okay, so you have 30 degrees and 45 degrees. Now, what is 30 degrees in radians? And what is the 45 degrees in radians? So 30 degrees is pi by 6. And 45 degrees right, so we said that we are looking for two angles which are standard, such that when we add them, they give us 5 pi by 12. So in this case, if you add those two angles, pi by 4 plus pi by 6, you see that what you are going to get will be 5 pi by 12. Right, so in this case, then we can use an appropriate identity, because here we are saying we are adding these two angles to get 5 pi by 12. So we are going to use the identity number 7 for us to be able to solve or find the exact value of the angle that we are given. So in this case, we are looking for the cosine of 5 pi by 12. And so we saw that this is the cosine of pi by 4 plus pi by 6. And so according to the identity number 7, this should be the cosine of alpha, which is pi by 4, and then the cosine of beta, which is pi by 6, minus the sine of alpha, which is pi by 4, and the sine of beta, which is pi by 6. Right, so now we have those standard ratios. So what is the cosine of pi by 4? Can someone tell me? What is the cosine of 45 degrees?
Over 2.
Right, so those standard angles, you need to know them. So you have root 2 over 2. And what is the cosine of 30 degrees? So you get root 3 over 2. And you have sine of pi by 4. Okay, so we can continue. I hope the people on Zoom have joined. So in this case, we have that the sine of pi by 4 is the root 2 over 2. And then the sine of pi by 6 is just 1 over 2. Right, so in this case, we just need to simplify. So we have root 2 times root 3, which I'll write as root 6, and then divide by 4, and then minus root 2 over 4. Right, so this is the exact value of the angle that we have been given. So we write it in this way. So it just be root 6 minus root 2 over 4. So that's how we can use these identities to be able to find the exact values of the particular angle that we are given. Is there any question or any clarification? Just go ahead if you want to say something. Yes?
When we say let alpha be equal to pi over 4 and beta be equal to pi over 6.
Mm.
Can either of them be beta or alpha?
Yes, it doesn't matter. Yeah. For addition may not matter, but for subtraction, of course, you may need to know which angle you are subtracting from which one. So you choose appropriately what alpha and beta will be in that case. But it doesn't matter. These are just symbols I've already told you. Alpha minus beta is just the same as beta minus alpha. Just looking at them as just symbols. Any other clarification? Right. Yes. Which one?
What is cos 5 feet over 12? Someone answered that it is 75 degrees, so I'm confused.
Okay. Did you attend the first lecture on trigonometric functions? On when we are looking at the radian measure. Right, so I don't want this angle to be in degrees because it is given in radians. So referring to degrees was just for you to be able to check what that angle will be in degrees. So that's what I was just doing. But converting as to whether that was 75 degrees, first of all, as a reference angle, if it was taken as a reference angle in the first quadrant, or as an exact angle at 75 degrees in the first quadrant, that is up to you to figure out. So can I leave it at that? Is that will be okay with you? Okay. Right, so if there is no any other clarification, we can move to other identities. So in this case, let me just remove some of these so that we are able to, okay. Right, so let's think of identity number 6. So identity number 6 is given as follows. Let me just push the board up a bit. So identity number 6 is given as follows. So we have that the cosine of alpha minus beta is equal to cos alpha cos beta plus sine alpha sine beta. Right, so we can use this difference formula, that's what it is called. So the difference formula for the cosine can be used to generate other identities. And these other identities are going to be as follows. Now, I want to use the, another letter. So let's say consider the following. So we have the cosine of, so if alpha is 90 degrees, so let's think of alpha as 90 degrees minus, I'll call beta A so that people don't get confused. So let's consider this difference here. So by 6, we have that this will be the cosine of alpha, the cosine of 90 degrees. So it will be the cosine of 90 degrees times the cosine of A plus the sine of 90 degrees times the sine of A. So that is by 6. But then we know that 90 degrees, we already got the ratios. So in this case, what you are going to get is the cosine of 90 degrees. What is the cosine of 90 degrees?
0.
All right, so you get 0 times the cosine of A plus, what is the sine of 90 degrees? That would be 1 times the sine A. Right, so in this case, you can see that what we get is just sine A. So this gives us another identity, which I'll call 8. So this identity is the following. So we have that the cosine of 90 degrees minus A will be equal to sine A. So that is what we get. Now, next, let's substitute. So let's substitute alpha A in 8. So let's substitute A with 90 degrees minus A. So in 8, let's substitute A by 90 degrees minus A. So in that case, we get the following. So we have the cosine of 90 degrees minus 90 degrees minus A. So where there is A, we just put 90 degrees minus A. And this is equal to sine of 90 degrees minus A. Right, so what we see in this case is the identity number 9, which we are going to get. So you can see here that we have 90 minus 90 plus A, which just gives us the cosine of A, will be equal to the sine of 90 degrees minus A. Right, so that is the identity that we get if we just do that substitution. Or the other way, you can use the identity number 7 actually and do what we have done here, and then that will give you another identity. All right, so the next identity then that we are going to think of is the following. So when we have the cosine and the sine, what we are interested in now is the tangent of 90 degrees minus A. So we have the sine of 90 degrees minus A. We also have the cosine of 90 degrees minus A. So this gives us a sine of 90 degrees minus A divided by the cosine of 90 degrees minus A. So sine of 90 degrees minus A is just sine A. It's the cosine of A. So we get the cosine of A, which is what we have here. And then the cosine of 90 degrees minus A, we got it as sine A. So then in this case, we have that tangent of 90 degrees minus A is that just the cotangent of A. So this gives us another identity, which I'm going to call identity number 10. So we have the tangent of 90 degrees minus A is equal to the cotangent of A. Right, so in this case, of course, we now can look at the other identities that involve the sine the sum of the sign or the difference of the sign function. Any questions so far before I raise this board? Right. So let's move on to the other identities. So we have 10 identities so far. You know them by using them, of course. So let's see, go back to identity number 8. So identity number 8 is the cosine of 90 degrees minus A is equal to sine A. So we want to develop the formula that involves alpha plus beta, or A plus B, if you want to put it that way. So what we are going to do is to replace A in 8. So replace A by alpha plus beta in 8. So we replace A by alpha plus beta in 8. So I'll rewrite it in this way. So I'll start with the sign. So A is alpha plus beta. So I'm starting from the right-hand side. This will be equal to the cosine of 90 degrees minus A is now alpha plus beta. So we just substitute there. And so what we get is the following. So in this case, let's rewrite this as follows. So you have the cosine of 90 degrees minus alpha, and then minus beta. So let's see what we have. And then we are going to use the cosine alpha minus beta identity that we have, which is identity number 6. So using identity number 6 on what we have here, what we are going to get is the following. So it will be the cosine of 90 degrees minus alpha times the cosine of beta, then plus the sine of 90 degrees minus alpha times the sine of beta. So this is by identity number 6. And so now we can simplify what we have. So the cosine of 90 degrees minus alpha, we saw in identity number 9, rather in identity number 8, that this will just be sine alpha. So this term just becomes sine alpha, and then the cosine of beta, plus this term also is another identity that we just found, which was identity number 9, which has sine 90 degrees minus alpha is equal to the cosine of alpha. And then you have that term, which is sine alpha. Right, so what we have developed now is an identity number 11. So the identity number 11 is the sine of alpha plus beta will be equal to sine alpha cos beta plus cos alpha sine beta. Right, so
I have a question.
Yes, please.
On sine 90 degrees minus alpha, the other term there is sine beta, not sine alpha. I don't know if
Sorry, come
sine
again.
90 degrees, sine 90 degrees minus alpha, I will say this cosine alpha. Then the other term is sine beta. Then
so it's the beta there, isn't it? All right, so in this case, of course, here I've used the two identities. So we have used identity number 8 and the identity number 9. Right, any other clarification or question? Okay, so again, if we replace beta by minus beta in 11, we get another identity. So in this case, if we do that, what we are going to get is the following. So we have sine alpha minus beta will be equal to sine alpha, the cosine of minus beta, plus cos alpha, and the sine of minus beta. Right, so we know that cos minus beta is the same as the cos beta. So in this case, you get sine alpha cos beta. Then sine of minus beta is the same as minus sine beta. So we have a negative sign there, which gives us cos alpha and sine beta. Right, so this gives us another identity, which I'm going to call identity number 12. So this identity gives us sine alpha, the cosine of beta, minus cos alpha sine beta. Right, so those are the identities that we have. And then, of course, we can think of the tangent. So the tangent of alpha plus beta, and also the tangent of alpha minus beta. Is there any question before I erase everything we have here? Okay. So the formula for the tangent of alpha plus beta, let's see how it is going to look like. So we have the tangent of alpha plus beta. By definition, this will be sine of alpha plus beta divided by the cosine of alpha plus beta. So we have already found what these are. So the sine of alpha plus beta is the sine alpha. the cosine of beta plus cos alpha and sine beta. So that's what we found. And then the cosine of alpha plus beta, in this case, is the cosine of alpha times the cosine of beta minus sine of alpha, sine of beta. Right, so this is by definition, what we have. So now, what we are going to do is to try and rewrite what we have in a different way. So, the first thing that we are going to do is for us to be able to divide both the numerator and the denominator by a particular factor. So in this case, let's do the following. Divide the numerator and the denominator . So we are going to divide by cos alpha times the cosine of beta. So both the numerator and the denominator. If we do that, what we are going to get is the following. So the cosine of alpha plus beta is going to be equal to sine alpha cos beta divided by cos alpha cos beta plus cos alpha sine beta divided by cos alpha cos beta. So that is the numerator. And then the denominator, we do the same. We divide by cos alpha cos beta. So the first term is cos alpha cos beta divided by cos alpha cos beta. And then minus sine alpha sine beta divided by cos alpha cos beta. Right, so then what we see is that when we do this division, of course, we have some common factors, if I can call them that way. So you can see that we have cos beta and cos beta there. And then here we have cos alpha and cos alpha. Here, of course, these two terms are the same. And then in this term, we have no common factors. So in this case, then what we are going to get is the following. So this gives us sine alpha divided by cos alpha plus sine beta divided by cos beta. Then in the denominator, we have a 1 there, and then minus sine alpha sine beta divided by cos alpha cos beta. Right, so in this case then, we are going to obtain another identity. Let me call this identity number 13, involving the tangent of alpha plus beta. So you see that here, this term is just the tangent of alpha. That term is the tangent of beta. And then divide by 1. If you look at this term, so you have sine alpha divided by the cosine of alpha. It is just the tangent of alpha. So you have the tangent of alpha. And then sine beta divided by the cosine beta is also the tangent of beta. Right, so this gives us that particular identity, which is identity number 13. And again, of course, you need to know this. Is there any question? So I can give you another. Yes, please go ahead. Well, not necessarily, but of course you need to know where they come from. And sometimes you may, in case you have forgotten actually how the identity looks like, you can derive it.
So some of us are having class. We are waiting for you to finish. Don't know how we are going to.
What time is your class?
They are joining so far.
At 11, at 10?
Yes.
I know that you have a class at 11. Okay, I have just 10 minutes. Let me just give you the last or another identity, which is the tangent of alpha minus beta. So in this case, all you do is just to replace beta by minus beta in 13. So you replace beta by minus beta in 13. What you are going to get is the tangent of alpha minus. So remember that now the sign, or rather the sign of beta, or which will be the sign of minus beta here, will now change to negative of the sign of minus beta. So you have the tangent of beta there, and then you divide by 1. So the sign here changes because when you replace tan beta by minus beta, the sign changes. So it will be 1 plus the tangent of alpha times the tangent of beta. Okay, so that is the formula that you can use whenever there is need to use. So you have 2 more identities, which are identity number 13 and 14. Right, so let me quickly give you just one example in the next 5 minutes. Right, so if you're looking at this, let's find the exact value of tan 195. So we have the tangent of 195 degrees. Right, so the first question I want to ask you is what 2 angles can you add or subtract to get 195 degrees, which are involving a standard angle.
We can use 150 and 45 degrees.
150 and 45 degrees. So what do you do there? You subtract. You add. Okay. Any other?
$135 and 60.
135 and 60. So we are saying that 195 is equal to 150 plus 45 degrees. And also 195 is equal to 135 plus 60 degrees, right? Now, if you look at 150, what standard angle does it give you? Yes, I have very 2 minutes, so I need to hear from you.
260 degrees and 130 degrees.
260 degrees and okay.
It gives a standard angle of 60 degrees.
It gives a standard angle 60 degrees. Right, so you can use either of the two. Let me choose to use the following because of time. So in this case, we'll have alpha as 135 and beta as 60 degrees. Then what is the tangent of 195? So that gives you 135 degrees plus 60 degrees. And by our identity, so this will be the tangent of 135 degrees plus the tangent of 60 degrees divided by 1 minus the tangent of 135 degrees times the tangent of 60 degrees. Right, so all the time, your duty is for you to be able to find the standard angles that give you particular standard ratios. So in this case, what is the tangent of 135 degrees? 135 degrees is in which quadrant? And which reference angle in the first quadrant are you looking at? Quickly tell me. All right, so the tangent of 135 degrees is -1, and the tangent of 60 degrees is √3. So we know, of course, we can find these ratios, and then you have 1 times minus the tangent of 135 degrees, which is -1, and then the tangent of 60 degrees, which is √3. So in this case, then you can simplify what you have and then get the standard angle that you are looking for. Is there any question? So you can also try to use 150 degrees and 45 and see what you are going to get. Any question? Right, so Like I said, you can just now, of course, rationalize the denominator. I will just leave it at that stage. Then you can, of course, finish up. So that is going to be multiplied by 1 minus root 3 divided by 1 minus root 3. And so once you rationalize the denominator, you should be able to find the 2 minus root 3 as your answer. Okay, so every time you are given an angle that is not standard, using what we have done, so we have a sum and a difference of two angles, you can find two standard angles that you can add to get that angle or subtract in order to get that angle and then be able to get the exact values. All right, so we'll meet again on Thursday. I'm wishing you all the best. I don't know if there's anyone who has an exam, but all the best if you have an exam.